Hi students, good morning. Welcome to this video session. I remain Samuel Dominic Chukwuemeka, aka Sam Dom for Peace. In this video session, we shall discuss the end behavior of the graphs of polynomial functions. It is important that you view the videos in the playlist. This is a video that is part of a playlist. Before continuing with this video, it is recommended that you view the videos in order. You view the videos in the playlist in order. The links to the videos and the notes can be found on my website, www.samuelchukwuemeka.com or www.chukwuemekasamuel.com. You can also go directly to this link, www.polynomial-functions.artspot.com, www.polynomial-functions.artspot.com. So I'm going to explain this, and you can write down, but it is recommended that you read the notes in this website. So it's better you just listen and see how I explain this, and then you can read the notes on any of the websites. When we talk of end behavior of a graph of polynomial function, we are looking at how does the graph behave at the ends. How does the graph behave at the ends? Is it rising or is it falling? You know, when we talk about rising, is it up, rising, or is it down? You know, when we talk of the left end and the right end of the graph, how does that graph behave at the end, at the left end and at the right end? Okay, at the negative x end and at the positive x end, how does it behave? So this is one of the topics in analyzing the graph of a function. It's one of the topics we encounter because this will lead us to actually sketching graphs of functions and analyzing the graphs of functions. So one of the topics there is determining the end behavior. Whatever we learn today, you can, in fact, actually I will encourage you to verify it by putting it in your graphing calculator. We will solve some questions here. We're not going to use graphing calculator here. That is the essence of this topic, to be able to tell the end behavior of the graph without having to even graph it. You know, without having to graph it, you can tell how the graph will behave at the ends. So, but I have some questions here we are going to solve. However, I will encourage you to check your work by actually putting these functions, the questions we will solve, putting it in your graphing calculator and see to verify. I would like you to verify. You can use your graphing calculator, you know, any of the graphing calculators, manually, well, the TI or the any of the web graphing calculators. So before we tell the end behavior of graphs, we are looking at two important things. We want to find the degree of the polynomial function, And we say that the degree of the polynomial function is the highest exponent, the highest exponent of the variable in the polynomial function when it is in standard form. It has to be in standard form. So before you find the degree, and we talked about this in previous videos, the degree of a polynomial function is the highest exponent of the variable in the function when it is in standard form. It has to be in standard form first. So if the polynomial is not in standard form, you want to put it in standard form first. Then you find the highest exponent. And putting it in standard form is just arranging it in terms of the highest in descending order of exponent. That is what I mean by standard form. We talked about this in previous videos. Just arrange the polynomial in descending order of exponents. Okay, so you need to find the degree and the leading coefficient, the sign of the leading coefficient. Sign of the leading coefficient. So these are two things you need to know in order to determine the end behavior of the graph of any polynomial function. You need to find the degree of the polynomial and then the sign of the leading coefficient. So, of course, the leading coefficient is after you have put it in standard form. So the polynomial must have to be in standard form. Must. It has to be in standard form. Standard form first. It must be in standard form. Alright, so when I don't like memorizing stuff, I like to understand it. There is a difference between understanding and memorizing. If you understand it, then even if you understand it, you can easily memorize it as well if you want to. So for this one, I don't like to memorize it. I'm going to show you a technique to easily spot it, so this, and we can write a summary. So let's look at this for now. Let's draw a table of values for y equal to x, for y equal to negative x, for y equal to x squared, and for y equal to negative x squared. So let us write a table of values. As usual, 5 values. 2 negative values, -2, -1, 0, 1, 2. Okay? Let's have this. X, y, -2, -1, 0, 1, 2. Here, x, y, -2, -1, 0, 1, 2. And here, x, y, -2, -1, 0, 1, 2. So let's write our table of values. As you can see here, this is x raised to first power, x raised to 1, x raised to 1. Okay, this is like saying 1x raised to 1, -1x, -1x raised to 1. This is like saying 1x squared, and this is like saying -1x squared. 1. I am using yellow chalk just to illustrate. you know. So we are looking at the degree. We have 1 is odd exponent, and 2 is even exponent. Okay, and then the coefficient, you are looking at positive and negative coefficients. So we have positive and negative coefficients. Okay, so this is what we're gonna do here. Say we have, the leading coefficient is equal to AXN, the leading coefficient. So we are looking at, I'm going to come here and draw 2 lines. I'm going to draw 2 lines here. So I'll have here N. N is the degree. Okay? Degree is N. Degree N. And then the sign of the leading coefficient, A. So that is all you need to find the N behavior. And we're going to look at how, you know. So I have here the degree N, and then I have here A. Let me have here A. So this N, I'm looking at N even degree, and then odd. And then A, I'm looking at positive. A is positive. So I'm going to put here N is, and here A is. So this is positive, and then negative. So folks, let's look at this for a moment. Let's get back to the table of values. Here, when x is -2, y is -2. When x is -1, this is y is -1. This is 0, this is 1, this is 2. Here, when x is -2, y will be -1 times -2, which is 2. When x is -1, y will be -1 times -1, which is 1. When x is 0, y is 0. When x is 1, y will be -1 times 1, which is -1. And then when x is 2, y is -1 times 2, which is -2. Here, when x is -2, y will be -2 all squared. Okay? When you have, when x is -2, so when you have x squared, it means -2 all squared. And that is -2 times -2. And that is 4. Okay? So this will give us 4, this will give us 1. This is 0, this is 1, this is 4. Now when x is -2, and then you're looking at -x squared. So this means -1 times x squared. That is what it means. It means -1 times x squared. So this will give us -1 times -2 all squared. Okay? So this will give us -1 times 4, which is -4. Because that's -1 times -2 times -2. Okay? I can write it if you want me to. So this is -1 times -2 times -2. That is what it means. And that gives us negative 2 times negative 2, which is negative 4. Any of the ways you want. Okay, so this is negative 4. This will give us negative 1. This is 0. Now this will give us 1 squared. Okay, if this is just 2, the negative, if you have this, when you have the same thing here, when you have x to be 1, so negative x squared is negative 1 times x squared, which is negative 1 times 1 squared, which is negative 1 times 1, which is negative 1. Okay? And the same thing if x is 2, it is negative 1 times 2 squared, which is negative 1 times 4, which is negative 4. So this is negative 1 and this is negative 4. Alright, so here, as you can see here, this is all you need. With this table of values, folks, I'm good. Honestly, with this table of values, just watch what I'm going to do. Now, for x1, x to the exponent 1, x to cube, x to exponent 3, x to exponent 5, x to exponent 7. For all, like with this, the trend you see here for this first one, x to exponent 1 is a linear function. It works for cubic function, for pentic, x to the 5, for heptic, x to the 7. So for all odd, it will follow the same trend. As you can see here, when this is positive, a is positive, okay, a is positive, and the degree is odd. Degree is odd. As x approaches negative infinity, as you can see here, as x approaches negative infinity, negative 1, negative 2, y also approaches negative infinity, negative 1, negative 2. As you see there, y approaches negative infinity. So, Americans will say approaches. Approaches. As x approaches negative infinity, y approaches negative infinity. Excuse me. Americans will say approaches. Nigerians will say tends to. Tends to. Okay. So whether you say approaches, or whether I say tends to, you know what I'm saying, tends to. That is that arrow, the arrow you see there. As x approaches, as x tends to negative infinity, y also tends to negative infinity. And as x tends to infinity, as x tends to positive infinity, y also approaches positive infinity. See that? So you're looking at this here. You're looking at this. If we have to graph, let me show you this. So, like, let's graph it, and you can see what I'm talking about. I'm gonna use this more space. So you're looking at this. Let's say I just sketch this graph for a moment. Here. And this is my y. So let me call this 1, 2, negative 1, negative 2. 1, 2, negative 1, negative 2. When x is negative 2, y is negative 2. So that is this. Of course, this will be your straight line. It's a linear function. When x is negative 1, y is negative 1. When x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 2. So as you can see here, it is what? As you can see here, as x approaches negative infinity, y will still approach negative infinity. And as x approaches positive infinity, y approaches positive infinity. So here, this is down on the left. Down on the left and up on the right. Down on the left and up on the right. So we write it here. So this is, because if you sketch this now, you see it here. Okay? You see, it's down on the left and up on the right. If you keep going left, it's gonna be that way, and then up on the right. And this works for x cubed, x fifth, x seventh. Okay, it works for all odd exponents, and then for positive leading coefficient. So this is down on the left, down on left, up on right, up on right. And we call this down up, down up. Or you can say fall, rise. You can also say fall on the left, rise on the right. Fall, rise. Down, up. That's it. Okay. If you do the next one, if we do the next one, the next one, y equal to negative 1x. 1. Of course, that's your negative slope. Okay? When x is negative 2, y is 2. So this is here. When x is negative 1, y is 1. That's here. When x is 0, y is 0 here. At the origin. When x is 1, y is negative 1. And when x is 2, y is negative 2. So here you can see up on the left, down on the right. So here, still odd, okay? You can, as s approaches negative infinity, okay, as x approaches negative infinity, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, y will be approaching positive infinity. 1, 2, 3, 4, 5, 6. Okay? As x approaches negative infinity, negative 1, negative 2, negative 3, keeps on, y approaches positive infinity. So y approaches positive infinity. Infinity. I call it 8 upside down. 8 upside down. That's what I call it, 8 upside down. Then as x approaches positive infinity, y approaches negative infinity. As x approaches positive, 1, 2, 3, 4, 5, 6. Y approaches negative 1, negative 2, negative 3, negative 4, negative 5. Okay? As x approaches positive infinity, y approaches negative infinity. So we call this what? Down, or you can say down on the up on the left, down on the right. Up, down, up, down. Or you can say rise, up, rise, rise, fall, rise, fall. Let's say rise up. Okay, rise on the left, fall on the right. Or you can say up on the left, down on the right. Up on the left, down on the right. Up on left, down on right. Okay, that's it. Now let's do the even exponents. If we have even exponents, so let's kind of make it, let's have some more space here. So with this, the main thing is this table here, which I don't want to memorize, I don't want to memorize it, so I prefer to just use table of values and get it right away. So if we do even exponents, let me show you x, y. We have 1, 2, 3, 4. Negative 1, negative 2, negative 3, negative 4. 1, 2, 3, 4. Negative 1, negative 2, negative 3, negative 4. When x is negative 2, this is for y equal to x squared. When x is negative 2, y is 4. X is negative 2, y is 4. When x is negative 1, y is 1. When x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 4. So this is your parabola. Okay, this is your parabola, quadratic, graph of quadratic function. Up, 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 up on left, up on right, up, up. As x approaches, as you can see here, as x approaches negative infinity, negative 1, negative 2, negative 3, y approaches positive infinity, 1, 4, 9. Okay? If it's x is negative 4, the next one will be 16. So y approaches positive infinity. Up, up. As x approaches negative infinity, y approaches positive infinity. And then as x approaches infinity, positive infinity, y also 1, 2, y also approaches positive infinity. Y approaches positive infinity. So this is up on left, up on right, up on right, or rise, rise. Okay, up, 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 up slash up, up, up. Or you can say rise, 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 rise. That's it. Rise, rise. Okay? And then when we do the next, this one, negative 1x squared, if we do that here, let's go ahead and do it here. Negative x squared. And this applies to x squared, x4, x to the 4th, quatic, x to the 6th. Hexic, x to the 8th, octic, x to the 10th. For even, it all follows the same behavior. The same behavior. Right? Like I said, this is the behavior at the ends of the graph. So if we have y to the negative 1x squared, negative x squared, negative x squared. Okay? When x is negative 2, y is negative 4. So this is going to be here. When x is negative 1, y is negative 1. That's be here. When x is 0, y is 0. When x is 1, y is negative 1. That's here. And when x is 2, y is, this here. When x is 2, y is negative 4. here. So if you join this, don't laugh at me, okay? Don't laugh at me. This is free, you know, this freehand. But I'm supposed to know how to sketch it right? I did engineering drawing. My first degree is in civil engineering, so I should know that. But anyway, so as you can see here, this is down on left, down on right. Down, 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 down. Now this is not the down, down, do your dance, do your dance. We're not dancing in mathematics. No, when I say down, down, do your dance, do your dance. How are you dancing in the down? Okay. So this is down, down actually. So as x approaches negative infinity, y approaches negative infinity. And as x approaches positive infinity, y approaches negative infinity. So we say it's down, down. As x approaches negative infinity, y approaches negative infinity. As x approaches infinity, y approaches negative infinity. So this is down, 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 or you can say fall, 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 fall. Down on left, down on right. Down on left, down on right. Now, as you can see here, it is actually the output. We are looking at x is the input, y is the output. We discussed that in functions. This behavior, this end behavior, is actually the behavior of the output. How does the output behave? How does y behave? You look at this here. Y approaches infinity. Y approaches infinity. You know, for this case, positive leading coefficient, even degree. Y approaches positive infinity. Y approaches positive infinity. Up, up. Here, negative leading coefficient, even degree. Y approaches negative infinity. No matter how the x is, y approaches negative infinity, y approaches negative infinity. Down, down. Okay? It's actually the behavior of y that we are looking at. You look at this case here, down, up. For this odd, for odd degree, and the positive leading coefficient. And the negative leading coefficient for odd degree is up, down. Is actually the behavior of the output, the behavior of the y. How does the output behave with changes to the input? And that is the essence of studying functions. Okay, how would the result be? We are concerned about the result, the output. If we change the input values, how would the output values change? Okay? Now, these are behavior at the ends. Let's do some few questions and then we can call it a day. But this is what you can memorize if you want to, you know. Like, you see, I didn't memorize, like, I'll be looking at it like I already understand. Once you understand it, then you can easily draw a table of values and just try this and then answer any question. All right, let's go ahead and now solve some problems. And like I said, you can verify these. You can verify it by graphing it. So first question I have here, I have f of x, function of x to be, here I have negative 3x to the 4th plus 7x squared minus x minus 6. So you look at this here, this is a standard form already. It is a standard form. It is a standard form, even though it is incomplete. Okay, it is incomplete, but it is in standard form. It is incomplete because the x cubed term is missing. x cubed term is missing. That is why it's incomplete. However, we don't care whether it's incomplete or complete. We just want to know, is it in standard form? Yes, it is in standard form. What is the leading coefficient? A is -3. What is the degree? Is 4. Okay, so here you now see, you look for a negative and even degree, and that's this. So the behavior, the end behavior will be down, 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 down. So if you go ahead now and graph this right now in your calculator, just check the ends of the graph. It's gonna be down on the left, down on the right. That's the end behavior, that's it. Okay, the next one we have P of x is 6x squared plus 3x cubed minus 2 minus 5x. Okay, you look at this question 2. It is not in standard form. It is not. We have to always put it in standard form first. It has to be in standard form first. Okay, you have to arrange the terms in descending order of exponents. So this is P of x is 3x cubed plus 6x squared minus 5x minus 2. Now it is in standard form. You have to always put it in standard form first. Okay? So once you do that, our leading coefficient here is 3 and our degree is 3. So positive leading coefficient odd degree, and that is down, up, down, up, down, up, down, up. Now, even if you put negative leading coefficient, if you put this like this, if you put this like this, just like this, without arranging it in your graphing calculator, it will still be down, up at the ends, you know. But for you to, I will always recommend, always advise you, put it in standard form first. Okay. Question 3, if you have this k of x to be, now look at this one here, x squared plus 4, 3 minus x, x plus 2 all squared. So look at this question here, question 3. This is in factored form. Factored form. It is not in standard form. It is in factored form. Factored form. Factored form. Okay. Please, you know, unless you want to really, I mean, you don't need to do the whole thing in standard form. You don't. Actually, let me first of all put this like this, x minus 3. Let me put this first, x minus 3, like this first. And then the next one we'll do 3 minus x. So, you don't need to come and start expanding, you know, you have the first one, the first factor is binomial degree 2. Second one is binomial degree 1. Third one is binomial degree 1. But it has multiplicity of 2. Later we are going to do multiplicities of zeros and their multiplicities, and then the rational zero theorem. We are going to do all those later on. So you don't need to come and start expanding the whole thing, multiplying the binomials. using FOIL for the first two and then multiply, you get a trinomial at the end. You don't need to do all those now. You can, what you could do, okay, what you could just do, actually when you multiply these two binomials, it's going to give you a tetramial, because you have x cubed, then you have 3x squared, then you have 4x, and then minus 12. So negative 3x squared, x cubed minus 3x squared plus 4x minus 12. That's a tetramial. Yeah. But when you have binomial, degree 1, you multiply it, it gives you a trinomial. That's by the way. Okay, you don't need to expand this, folks. You do not need to expand this, no. Just look at the leading terms, okay? So you just do this now. Find x squared times here x times, now this here is x, you know, if I have to kind of show you something, this means x squared plus 4 times x minus 3 times x plus 2 times x plus 2. This is what it means here. So you're looking at this guy times this guy times this guy times this guy. You see that? Okay, you see that? So this is, we're looking at the leading coefficient. You know, when you put all of them in standard form. But in this case, you don't need to come and start multiplying all these. No. If you're asked to just find the end behavior, you don't. And you can just put this like this in your graphing calculator. It will graph it and tell you and you can see the end behavior. Okay? But if they just ask you find the end behavior, you don't need to multiply this. You don't need to. Okay? Just find the leading terms. X squared times x times x times x. And this gives us what? X 3, 4, 5. X to the 5th. X to the 5th. See that? This gives us. So the leading term here, the leading coefficient is 1 for this. The leading coefficient is 1 and the degree is 5. So here A is 1 and is 5. So positive odd, and that gives you what? Down, up, down, up, down, up. See that? Does it make sense? All right. Let's go ahead and do 2 more questions and then we can call it a day. Question 4. We have g of x to be x squared plus 4. Actually, we have 3 more questions. 3 more. Okay, I just saw it here. X squared plus 4, then 3 minus x, and then x plus 2 all squared. Okay. Now look at this case here, folks. You see this guy here. This guy is kind of tricky. Because you have to put it in standard form, remember? So this is x squared plus 4. Now this is minus x plus 3. You see that? And this is x plus 2 times x plus 2. So just be careful in this case. Okay? So this will give us x squared times minus x times x times x. You see that? So this is minus x5. So with minus x5, a is minus 1, n is 5. A is minus 1, n is 5. So that gives us what? Negative odd. And negative odd is up, down, up, down, up, down. See that? Okay, question 5. if we have p of x to be negative x minus 2, x plus 4, 2x minus 3, x plus 1 all squared. Like I'm trying to do varieties. So you can be acquainted with it. Okay? So this gives us what? This gives us negative, this is negative 1, let's not forget. Okay? So this is like saying negative x, you can put negative 1. You can just go ahead now and put negative 1 times, you get this x here, you get this x here, you get the 2x here, and remember this is x and x, remember. If you want to split it, that's fine. Do you want me to split it? Would you want me to split it? Negative x minus 2 times x plus 4 times 2x minus 3 times x plus 1 times x plus 1. Okay? So 1, 2, 3, 4, 5. So this is x times 2x times x times x. You see that? So this gives us what? Negative 2x5. Negative 2x to the 5th. So our a is negative 2 and our n is 5. Okay? So this is negative leading coefficient and odd degree. And that is what? Up, down. Up, down. Up, down. Alright, last but not the least, question 6. Last but not the least. And if we have p of x is equal to x squared plus 4, 3 minus x all squared, x plus 2 all squared. So it's still the same, just be careful, just be careful. But it's still the same thing we've been doing. Okay, so this will give us what? This is x squared plus 4 times negative x plus 3 all squared. You want to put it, in standard form. Okay? Then times x plus 2 all squared. So this is like saying x squared plus 4 times negative x plus 3 times negative x plus 3. And you must not do this. Because what if you have raised to power 3 or raised to power, okay, what if you have raised to power 7? I want you to be able to, actually we will do that next to make it question 7, right? Just for you to understand what I'm saying. Okay, so you mustn't always break it up. I want you to be able to kind of know what it will be. So times x plus 2 times x plus 2. So you now get out this x squared times negative x times negative x times x times x. And that gives us what? Negative times negative is positive. So that's okay. So 2, 3, 4, 5, 6. X to the 6th. X to the 6th. Okay? So this means that a is 1 and that degree is 6. So positive even degree. Up, up. Up, up. Alright. Now don't worry. Last now but not the least. Because so I'm thinking of questions that you might ask me and I want to cover it right away. How about that? Okay, what if we have this last one, f of x to be x squared plus 4 all cubed, 3 minus x all 7, and then x plus 5 all 5. Okay folks, how about this now? Okay, so this is now x squared plus 4 all cubed minus x plus 3 all 7. You want to put this in standard form. You want to do that. Then x plus 5 all 5. Actually, let me do this 2x. 2x plus 5 all 5. Okay, so this is what we're going to do. We're going to do this here. X squared all cubed times negative x all 7. So you see what I'm doing? Because it's negative x times negative x times negative x. You must not write everything out. You must not. Okay? And then times 2x all 5. You see that? So this gives us x raised to power 6. Laws of exponents. Laws of exponents. Now times this here, because this is odd exponent. I mean, if you have a negative base and an odd exponent, it will give you a negative result. Please review my videos on exponent. Review my videos on exponent. Times, this is 2 exponent 5. X exponent 5. So this gives us now negative x exponent 13 times 32 times x exponent 5. So this gives us negative 32 x exponent 13 plus 5 is 18. X exponent 18. We see that? Right? Does that make sense? So please, you can view my videos on exponents so you can become familiar with all this. So we now have that our A is negative 32, A is negative 32, N is 18. So negative and negative even. Negative even is down, down. That's not down, down, here. So this is down, down. Okay, and we're going to stop here for today. 7 questions. If you have any questions at all, please feel free to ask. Look out for further videos on polynomial functions. Please make sure you view these videos in order, and you have a great